Hello everybody. Today in this video we are going to see about the textbook problem solution. This is the third problem in chapter 11. Synthesize the LC driving point impedance. That impedance function is given here in the form shown in figure. Determine the element values of networks in henries and farads. We are given a network. The impedance function, it is look like here. This is series capacitance, parallel inductance and parallel tank circuit of LNC and parallel capacitance C3. We have to determine the values of this network. You can realize it in any form, just like a faster 1 form, faster 2 form, or car 1 form or car 2 form. Here if you watch this one, it look like a capacitor and inductor, which is series and parallel combination. So it looks like a car 2 form. Okay, this part looks like a car 2 form. And this part looks like a faster 1 form. So you can do that car 2 form, that is the lowest order continued fraction expansion, and we can get a quotient value. From that quotient value we can determine the capacitor C1 and L1 inductance value and proceed with the remaining terms. Just like a faster 1 form, that is just doing the partial fraction, we can find out the L2, C2 and C3. Instead of doing that, we can find out the elemental values by simplest way, just like at the input end there is a capacitor C1, so it represents a pole at origin of an impedance function. Since it is in series connection, it represents an impedance function. So C1 represents a pole at origin at this impedance functions. So we have to first find out the pole at origin. Next one, we have a L1, which is in parallel connection. So L1 represents the pole at origin of admittance function. Okay, and this might be in that format, Ks divided by S squared plus omega squared. So it is somewhat complicated. So instead, before going that, we can find out this capacitance. Again, this capacitance represents a pole at origin of impedance function. So it represents pole at origin of impedance function. It represents pole at origin of admittance function. Admittance function. It represents pole at origin of impedance function. So remaining residues will be your Ks divided by S squared plus omega squared. That is, remaining residues will be your parallel tank circuit L2 and C2. So we are using this method. Okay, is it clear for you? So first, C1 represents pole at origin of impedance function. So given function is also a impedance functions. So pole at origin. For that, we have to take S as common. If taken pole means, so from the denominator. So if we take S as common, it represents S into S squared, S power 4 plus 18 S squared plus 48. Pole at origin S equal to 0. So by putting S equal to 0, this getting cancelled. So 48 divided by 48 gives 1. So this S, pole at origin, so which is 1 by S. Okay, 1 by S represents a capacitor at the origin with the value of 1 farad. So C1 value might be 1 farad. Okay, clear? So this network C1, that is 1 farad, and the remaining term will be your remaining impedance Z1. So this is Z of S. So 1 by S plus Z1 will be your Z of S, which is given here. So Z of S, this one. So 1 by S plus Z1. Okay. So we have to find out the remaining term. Remaining term means Z1 of S. Here Z1 of S, first term will be your inductance L1, which represents pole at origin of admittance function. So we have to first find out Z1 of S. Z1 of S equal to Z of S minus 1 by S. Since Z of S equal to 1 by S plus Z1, Z1 might be Z minus 1 by S, which is given as. So this term will be 5S cube plus 24S divided by S power 4 plus 18S square plus 48. But the inductance which is in parallel connection, so we have to take the admittance. Reciprocal of Z1 will give on Y1. So Y1 equal to S power 4 plus 18S square plus 48 divided by 5S cube plus 24S. So we have to remove the pole at origin. So Y1 term equal to, numerator will remain same thing. Since it is a pole, we have to take an S at the denominator. If it is a 0, we have to take a common S at the numerator. Okay. So 5S square plus 24. If we put S equal to 0 here, everything will be cancelled. Remaining 48 divided by 24. 48 divided by 24 gives 2 by S. Okay. So 2 by S plus remaining in admittance functions will be Y2. That is capacitor of 1 farad, inductor of 1 by 2 Henry, and that remaining term will be your Y2 admittance. So which is given like here, 2 by S plus Y2. So Y2 will be Y1 minus 2 by S, that is S cube plus 8S divided by 5S square plus 24. Okay. Again, remaining term, what is L2, C2? This is a complicated term. So we have to first find out C3. So C3 means pole at origin of impedance function. So we have admittance, we have to find out the pole at origin of impedance function, which gives your C3. So reciprocal of Y2 gives Z2, 5S squared plus 24 divided by S cube plus 8S. Again we have to put S equal to 0, so we can get 3 by S plus 2S divided by S squared plus 8. 3 represents your capacitance value 1 by 3 farad. Next, the remaining term will be your L2 and C2. That is 2S divided by S squared plus 8, which is in the format of Ks divided by S squared plus omega squared. So 1 by K represents your capacitance value. What is here K? 2. So 1 by K means 1 by 2. 1 by 2 farad is your C2 value here. Okay. Next, 1 by K infinity. K infinity represents your inductance. 1 by K infinity equal to omega squared, K divided omega squared by K, 1 by 4. Okay, K divided by omega squared, 2 by 8, 1 by 4. K infinity represents your 1 by 4 term, 1 by 4 Henry. 1 by K. K infinity represents your K by omega squared. So 1 by 4 Henry. So this is your elemental values of a network. Is it clear? I have put those values in the figure. This is of 1 farad. 1 farad. This is 1 by 2 Henry. 1 by 4 Henry, 1 by 2 Farad. This is 1 by 3. This is the solution of this problem. We have to find out the elemental values of L1, C1, L2, C2 and C3. Okay, is it clear? Which is given here. If you have any doubt, please put your doubt in comment box. Okay, thank you.